Good afternoon, Year 7. Today's lesson is on sorting with Venn diagrams, and it is our last probability lesson. So make sure you've got the title written down, please. You might have done Venn diagrams before. You might have done them at primary school. Venn diagrams are a way of sorting different elements into different groups. Now, the elements will have to come from a set. So first of all, we're going to write down what a set is. So a set is a collection of elements. And to identify a set, we use curly brackets. So, for example, I could have the set of integers from 1 to 10, and that would be curly bracket 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I could then sort that into some different groups. So I could have multiples of 3 just from this set, and that would be 3, 6, and 9. I could also do prime numbers. And that would be 2, 3, 5, and 7. So a set is a collection of elements. Here, in integers from 1 to 10, the elements are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can then make subsets, so multiples of 3. The elements from here would be 3, 6, and 9. And the primes would be 2, 3, 5, and 7. So pause the video, please, and make sure you've got all of this board copied down. And now make sure you've got this bit copied down. Now what we can do is we can sort the integers from 1 to 10 into the two sets, multiples of 3 and prime numbers, and any remaining numbers in a Venn diagram. So, for a Venn diagram, some people forget that you have to draw the box as well as the circles. We draw a circle for each subgroup or subset. So we need one circle for multiples of 3, and we need one circle for prime numbers. So I'm going to write M here for multiples of 3 and P here for prime numbers. In this part of the M circle, we put the numbers that are only multiples of 3. And in this part of the P circle, we put numbers which are only prime. But in the middle goes numbers which are prime and multiples of 3. So those are the ones we need to identify first. So if we have a look at the prime numbers and the multiples of 3, we can see that 3 is in both. So that is going to go in the middle. Then multiples of 3, we've still got 6 and 9 left. So 6 and 9 need to go here. And then in the prime numbers, we've still got 2, 5, and 7. Now, it was actually the numbers, the integers from 1 to 10. So 1 isn't in here, so that goes outside. 2 and 3 are both there, but 4 is missing, so 4 goes outside as well. It doesn't matter where outside you put it, as long as it's inside the box and outside of the circles. 5, 6, and 7 are all there, but 8 is missing. 9 is there, and 10 is missing. So if I want to take the integers from 1 to 10, and I want to sort them on a Venn diagram into multiples of 3 and prime numbers, this is what the Venn diagram would look like. These are all the numbers that are multiples of 3 and prime numbers, and it's only 3. These are the multiples of 3 which are not prime. These are the primes which are not multiples of 3. And these are the integers from 1 to 10 which are not primes or multiples of 3. So that is how we would fill in the Venn diagram. If you have a look on the worksheet, they've done another example which uses shapes. There's triangles and green shapes out of a subset of a green triangle, a green circle, purple triangle, green triangle, pink triangle, and green parallelogram. So have a look at that one as well. But this is the one I've done. On this one, I've listed each individual element. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. However, what you can also do is instead of writing the elements out, you can just write how many there are. So in the multiples and primes section, I could say, well, there's only one number that is both. In the primes section, I could say there are 3 numbers that are prime, so 2, 5, and 7. And then in the multiples section, there are 2 numbers that are multiples. And that left 4 numbers outside. However, that can get quite confusing when the elements are numbers. So when the elements are numbers, we tend to write the individual numbers in. On the worksheet, however, where the elements are shapes, we can just write down the number in each group. Make sure you've got that last bit copied down. Go back and pause the video if you need to. And then we're going to write down this key bit of information, which is that Venn diagrams use circles to sort objects into sets. If the elements are numbers, we put all the elements in the Venn diagram. So that's like what we just did. However, if you look on the worksheet, if the elements are not numbers, we can just write numbers on the Venn diagram to show how many elements are in each set. So pause the video and copy that down, please. And I'm just showing you this now. So this is the worksheet. This is part of the worksheet. So this is the difference between the Venn diagram I've done and the Venn diagram they're doing. Here, the elements are the shapes. So green circle, purple triangle, green triangle, pink triangle, green parallelogram. And they've been sorted into the 3 different types of triangle and the 3 different green shapes. So now, if they want to do a Venn diagram of triangles and green shapes, there is 1 green triangle in these elements here, so we put 1 in there. There are 2 more triangles which are not green, so that's where the 2 comes from. And then there are 2 more green shapes, so 2 goes there. And this is 0 because there aren't any shapes which are not either green or a triangle. So there's no shapes that are both not green and not a triangle. So hopefully that makes sense as to how we set up a Venn diagram. And now we're going to learn about different regions on a Venn diagram. So we can describe regions on a Venn diagram using words. There are three words: intersection, union, and complement. So the first one we're going to do is the intersection. Is where two sets overlap. And we would write it as A intersection B, and that means that an element is in both A and B. If we draw out what area that would be, it is this bit. So it's when an element is in A and B. So it doesn't mean in A or B, it means it has to be in both of them. So that is the intersection. Pause the video and copy that down, please. The union is the combination of both sets, so the combination of two or more sets. We write that as A union B, and it means the element is in A or B. If we shade in the region represented by that on the Venn diagram, the element can be in A or B. So it's everything in the two circles, and we're just ignoring what is around the outside. So pause the video and copy that down, please. The last one is the complement. The complement of a region is everything except that region, and we denote it with a little dash. So A dashed means the element is not in A. This is not a dash, this is just like quotation marks. In fact, I'll make them double and then that'll make it a little bit more obvious. So what region is that on a Venn diagram? If we have a Venn diagram, A and B, we want everything which is not A, so it has to be not in A. Well, A is this circle, so not A is everything outside of that circle, and it will include the bit of B that does not overlap with A. So that's the region that, where I've shaded in green, that is the region not in A. Make sure you have all three of those copied down. Go backwards in the video and pause it if you need to. And now we've just got an example to do. So here is the example that we're going to do. So can you pause the video and copy this out, please? So Keisha asks 24 students in her class about their families. She sorts them into S, which means the student has a sister, B, which means the student has a brother. And this is shown on the Venn diagram here. The things we have to do are A, describe the orange region, B, describe, and I've spelt describe wrong, describal. B, describe S dash intersection B dash, and C, how many students are in S dash. So first, describe the orange region. The orange region is inside of the S circle but misses the intersection of S and B. So these are students who do not have a brother or a sister. These are students who only have a brother. These are students who only have a sister. And these are students who have both. So actually the orange region is students who have a sister but do not have a brother. So again, I'm going to move the board and we're going to write that down, and I'll bring the board back. So A, copying this down please, the orange region is the number of students who have a sister but not a brother. Pause and copy that down, and then I'm going to put the board back. Okay, so the next one, describe not S intersection not B. So not S, so it can't be any of this circle. Intersection not B, so it can't be any of this circle. So that must be students who don't have a sister and don't have a brother, and that will be 4. So not S intersection not B represents students who do not have a brother or a sister. In fact, let's change that. Let's say who do not have a brother and do not have a sister, just to make it really clear. Okay, so make sure you've got that copied down, please. And then finally, how many students are in S dash? So this means how many students do not have a sister. The dash means do not and S means sister. So how many students do not have a sister? These 7 do have a sister. They only have a sister. These 5 have a brother and a sister. But these 8 only have a brother. And these 4 don't have a brother or a sister. So there are 8 plus 4 equals 12 students in S dash. And that's the end. So make sure you've got all of that written down. Pause the video if you need to copy it out. And that should be everything you need to do the question sheet that I've put on Show My Homework.